Yeah,
You're done. You can open it.
Because they would only look
Oh, you can plug it in, yeah.
I had some major farewells this week. I had a meeting one night late and tried Google Hangouts, tried like a FaceTime, even tried a phone call.
Phone call would work?
It would work.
What did you end up doing?
Doing it in Discord, which was awful.
I don't understand.
It's like Slack.
Oh, okay. That's really hard to do a meeting in.
Oh my gosh, it took an hour.
What was this, like a planning meeting? Chatting.
A phone call?
No, it's not that even that. He's just chatting the entire time. And the entire interview, like an hour-long conversation, was a chat. And it was likely so that they could not know who I was. Like,
It's an interesting
no,
idea.
there was no race bias. There was no what you look like, bias.
Yeah.
And it was all about how you interact in the
Ryan
tools
could be
that
a girl's name.
I had a classmate that was a Riley, same spelling.
Yeah.
But it was how you interacted in a tool that they used daily. They used IRC and Skype to communicate amongst the colleagues, but only turned on video when they needed to have like high fidelity. So the whole thing, and then they could copy and paste my interview and archive it if they needed to, and let other people review how well I answered questions.
You can just do voice too, like a phone call. That works well like
Sure, but they didn't even want that. They
Yeah.
didn't want voice. They
No
just
voice.
wanted to
How
copy
many
my
use our tool set?
Right.
Yeah.
Yep.
I think we're ready.
Well, thank you guys for all coming out this week. So a little bit of housekeeping. So next week we will be having Drink with Geeks at the Will House. So make sure you bring some dollar bills or some quarters or something so you can
Play with the wheelhouse is.
so you can play some arcade games with us. They have food.
It's an arcade.
Yeah, so it's a bar in town that has food, and they also have a bunch of arcade stuff there. So, and we're playing quarters. I'm just kidding. And then, so next month we're still looking at who's going to be doing the talk, and so we'll post some of that once we get closer to time. Tonight we have Brian and Tarakesh, and they're going to be talking on writing native applications. Tarakesh will be doing it, talking about it with an Electron, and Brian will be doing, I had to get it because I couldn't remember the acronym, QT and QML, which is C++, right?
It's a bunch of them.
A bunch of languages. So help me welcome them. And Brian's presenting first, so I'll let him take it over.
Okay. There you go. Okay. So this talk is on what I like to call, this sounds fancy, but it's really not. It is modern declarative GUIs, graphical interfaces. And I should kind of pretext this that this started off as a web programmers thing, and most of you guys are web programmers, and I don't like web programming, and I really don't like JavaScript, and so maybe this is my way of getting back and saying, hey, this is all the cool stuff you can do without having to do web. Tarakesh talks about how you can make hybrid applications that run on the desktop with the web technology, so you guys will probably like that part better than mine, but.
I just have been doing a lot of native-ish stuff recently.
So the question is, why would you want to go with the native graphical interface app instead of a web application? And the first point here of performance, that is a big one for a lot of stuff. If you're running natively on your computer, there's no sandbox. You can compile the code down as much as you want. The less RAM is really big if you've ever used the Slack app. A simple chat application can take hundreds of megs of RAM. It's just crazy. There's, like I said, there's no sandbox, and so you can get to the actual facilities of the operating system. If you need to do something within Windows or something within Linux, you basically have to run a native app to do that. You also have like full network access, and full file access. And of course, web apps, you want them restricted from these things for security reasons. But sometimes you want to run stuff you don't want those security reasons. One of the big things that I work for the University of Alabama, and we write software for law enforcement, and the disconnected aspect is important for a lot of our things, because if you're a police officer in your car driving through Mississippi, you're not always going to have an internet connection. And so a lot of our apps are either native or hybrid, so that they can run when there's no internet. And you also get a cleaner GUI. You don't have all the browser weirdness, and you can optimize that. So for my interest, some of the stuff that I'm doing in native apps is I'm playing with sound generation and modification apps, and that one really needs to be run native, because you need to have real-time control over your sound coming out. I'm working on an oscilloscope interface, and again, you want the good performance, and you need to be able to connect to devices attached to the computer over USB or over the network. And Wes has done this a lot with the AI. If you're working with multiple threads, you're running stuff on the GPU. There's web apps can do a lot of this. That's the disclaimer. Web apps can do a lot of this stuff, and they're gaining more capabilities all the time. But it still reaches a point where sometimes you just got to get all the way down and run a native app. So I'm kind of breaking the whole GUI toolkit thing down into two generations. This is the first generation. This is imperative GUI toolkit. So I'm just going to take that and contrast it against the declarative. And so these ones are all code, constructed line by line. It's often object oriented. And these things have a really simple execution model. They're fast because everything's compiled. But they have poor separation of view and logic, and their design tools are cumbersome. And so, like, this is an example. This is called a Flick, FLTK, and this is an example of one of these imperative applications. And you can see, if you look through here, this is just straight C++ code. Every time you put a button in, every time that you put a window in, you're creating a C++ object. And so this is nice because it is just C++, but if you want to open a editor and then drag things around and make your GUI, the programmer you're using to create the screen for you then has to output C++ code, and that gets you into all sorts of weirdness. And again, the poor separation between view and logic. If all this is C++ code, people become very, very tempted to put more program logic right here, since it's already C++ and they should. And so in contrast, this is what I'm calling the declarative GUI toolkits. And actually, this part is incorrect. I forgot to change that. And so for the declarative GUI toolkits, instead of having your program logic, having a programming language for your layout design, you have some other method of it. And so this right here is what's used in XAML in .NET. I actually stole this from one of our programs at work. And so this is all XML.
You all good?
And so you can see that this XML says there's an image, there's a text block, there's a grid that lays stuff out. And so and actually this is pretty reminiscent of HTML. This is a layout language that you use for saying this goes where, this has this text, and all that sort of stuff, aside from your actual programming logic. And so this is the point I'm making with the declarative side is it helps a lot. And in my mind, this is something that was stolen from the web guys, and I could be wrong about that, but there's probably people who were doing it before, but it became really popular when the web guys were saying, well, here we have HTML, and then we have all the logic separately, and then the GUI guys are like, well, how come we're not doing that? Mm-hmm. So like I said, this is XAML. This is just an example of it. But the one I'm going to be talking about is Qt, and so Qt is a multi-platform windowing library, graphical library. If you've ever used KDE, a lot of the applications written for Linux or cross-platform, they're going to be compiled onto Qt. Now, Qt can run in the imperative mode. You can write C++ code and create everything by hand, but fairly recently they came up with what they call QML, which I'll show in a second, that defines that layout language separately from your program logic. it's kind of funny because Qt was independent, and then Nokia bought it as one of like 6 different graphical toolkits they're trying to develop at the same time. And then Nokia, kind of went away, and it came back to independent. And since this is one of the really, really popular ones, I mean, it has bindings in everything. It has C++, Python, Haskell. It's almost like if you can name a language, there's probably a Qt binding to it. It also runs on everything. This is designed for mobile applications, desktop applications, whether you're Linux, Mac, Windows, BEOS. I mean, this is probably more compatible than anything else out there. And so the program I wrote for an example here is something called Cam Clock. And so what happened was one of my friends, the student that Tarakesh knows, had a problem where he was doing an experiment on mechanically stressing a part, and it needed to be checked every 2 hours to see if it had developed cracks. But this runs for a couple days, and as you can imagine, as a graduate student, it's like every 2 hours you have to be in the lab to look at this thing to check to see if your crack's grown. And it was driving him crazy because he could never get more than like an hour and a half worth of sleep. It only takes 2 seconds to go on and check and write down did it grow or not, but that would just kill you. And so he called up and he's like, Brian, help me. And so I came up with a Raspberry Pi with the PiCam, but the problem is you need to take really high resolution video, and high resolution video, and since it's moving, you need a high frame rate. If you do that all the time, you're not going to be able to store it all. And so I wrote a little kind of cron-like application that will do it, and this is the configuration program to set that up. And so the first part to it is let me see if I can make this bigger since we're on the small screen. This is the QML file. And so this is the file that defines the layout, and you can see it's rather similar to JSON, right? We import the stuff we're using. Here's the main window, and then we come here and we have a column. Within the column, we have a grid layout, and then you can see here, we have a text that's the start time. We have a text field for the hours and all that. And so when we run this, this is what it looks like. Now, the cool things about this is that in here, they have this QML where you lay it out in a JSON-like file, and then you can also inline JavaScript. And so, the temptation is to start putting lots of logic into your view layer, which you don't want to do, but like this is a little bit of JavaScript that could be written better, there's ways you do it without the JavaScript. I wanted to put it in to show that you could. This goes through, and if you run this and you put your start time to be hour 56, that's obviously not right, and so we'll highlight it in red for you. And so that's a little bit of logic that I put in using JavaScript in the view file in a C++ program. And you could easily bind this to a Python program, and so your Python program could be running the view model that's running JavaScript. But if you get into this further, like here, down here on the when you click save, this calls mysaver.save parameters. And if you look over, this is the main file. This is like 6 lines, basically just starts it and says run this all in QML. But we have this saver object here that has a save parameters function, right? And so I could take this, and this is in C++ or whatever other language I bind it to. I can put my application logic here where it's really quickly. This could be running a simulation or anything else you wanted to in C++. And the save parameters gets called from the QML file here, and it's like JavaScript down through the layer into C++ native code to run you what you want to run. And so when we run this here, and when we click save, I don't know if you can see it down here. Like if we change the time to be 12:34. And we go to save it, it's saving that all the way down through all the layers into your C++ code. So, and this is also nicely resizable. Like I said, so it flows back and forth and all that sort of stuff. So
How did it work for the student?
I just have the interface finished. I haven't written the back end to it yet.
Okay, okay. I thought you'd already done
No,
it.
well, I did set it up as just a cron job that runs,
Yeah.
but this allows more flexibility because like when he's starting off, he wants to take them every 5 minutes,
Yeah.
and then later on he wants to move to taking it every half hour.
Wow.
And so like you can start at 12:34 and then say I want to run it 5 minutes later, and then I want to run it 10 minutes after the start time, and then I want to run it every 30 minutes after that on repeat. So.
And what would happen if you check the top line for repeat? Would it never get off the 5-minute interval?
Well, this is just a configuration program,
Okay.
so I haven't figured it out yet.
Okay.
This is like, I mean, I actually didn't want to put programming logic into this because that kind of clutters the example.
Sure.
And you can see it's just labels and text fields and things like that in here.
It's just capturing input.
Yeah. This would just be capturing input. The idea is this would write out, either a pickle file or a JSON file, and then the server process would run and pick that up to do what it needs to do. So, any other questions, comments? Have any of you guys written native GUI code? I know Wes has a little bit for the Palmer man.
In coursework.
Coursework and recent work.
Yeah, I mean, the first job I had while I was in college and after college was at a physics lab, and so we had a lot of native applications for doing physics analysis and talking instruments and things like that. And then I, came out and worked for UA, like I said, writing software for police officers. It's another one where we're doing a lot of rich applications. So, and if you go back here, I actually tried at one point writing using the Haskell bindings to FLTK here for Flick. And it was a horrible experience trying to write a imperative type paradigm in Haskell. This was just completely messy. So I'm looking forward to using the Qt and the QML tasks. I think that'll work a lot better. So
In college, I think most of the UI stuff we did was imperative stuff, and it was just nasty. It would just be like this much code to do a simple little button. You're like, what is up with this?
well, and a lot of it is, if you look at this, it is literally setting this is the x coordinate, this is the y coordinate, this is the width, this is the height, right? I mean, you're laying everything out pixel by pixel on the screen, which again comes into this often difficult to adapt to screen sizes.
Yeah.
Whereas here you can define things a lot more flexible. Where I can say, this is the minimum size. This is a grid layout. This is how I want it to be horizontally centered. Here's the minimum size if somebody tries to make it smaller, and all sorts of stuff like that. Which is, hugely important if you're doing things like programming for mobile, because there's so many different screen resolutions and sizes and tablets and all that. So this allows you to make it responsive, since you're not tied into the. You can make it responsive by setting all your sizes and all that manually, but that becomes a huge.
So they change too often.
Yeah. Okay. So any other questions, comments?
I'm interested after you get it up and running, how it works, how the grad student, how not. I know it's going to work for him, but I'm just curious to.
Well, so that's maybe one of the benefits of this is because it's native, then drivers of the camera or whatever else, it can connect with those things a little bit better than maybe if it was a web app.
So the reason I'm making the configuration for a native application is I didn't want to go through all the overhead of having a web server running on the Raspberry Pi in order to serve out the configuration page. And I didn't want to go the Electron route, because that just adds a whole bunch of complexity for what is a really, really simple 9-field application.
Yeah.
So. And so here's Tarakesh to prove me wrong, I guess.
All right. Well, thanks, Brian.
Okay, Brian, come on the lights real quick so the camera can see Tarakesh.
Okay.
I'm blinded!
I'm sorry. Always. I know. Why are they not on two different switches? That's just.
Be careful with the
Yeah.
fire hazard.
We're protected. We're fine.
Everything's fine.
Everything's fine.
You can just, yeah, there you go.
He's a web programmer, works with me, University of Alabama, and he's really good at the front end web stuff. So this Electron is a good way to use those skills. So
Thanks.
And you've got a.
Is it working?
Yep.
That's fine.
There you go.
So today I'm going to be talking about hybrid apps. So just now, like Brian was talking about native apps, and you know how if you are creating a native app, you have to use that native platform specific tools which are provided by the platform creator. For example, if you're creating an Android app, you have to use Android Studio, or if you're creating an iPhone app, you have to use OS X Xcode to build an iOS app. So, but native apps provide you with the whole native functionality and the whole native functions and features for an application. But there's a problem, because if now you have written an app in Android, and now you want to write the same app in iOS, then you have to write the code again into another platform. So it's like you're writing duplicate code, and that's excess of work. So here web apps come into picture, wherein web apps, you can access them anywhere on all the devices, on desktops, everywhere, on desktops, mobiles. But the problem with web apps is you cannot access the native features as good as the native apps. So that's a drawback of web apps. So I would like to say a hybrid app is the love child of a web app and a native app.
The sneak in love trial like we're not.
Yeah. So it gets the best of both the worlds. So a hybrid app is basically a web app which is contained into a native wrapper, which
It's so cute.
which is contained to a native wrapper, which gets all the native functionalities, and then you can just ship it to the App Store or Google Play, whichever place you want it to. Why hybrid apps? Hybrid apps, just like I said, the drawbacks of native apps. Like you have to write the code again for if you're creating an app for iOS, or if you're creating an app for desktop. So code duplicacy, you don't have to do that. You don't have to write. You just have one code base, and you can use that for all platforms. That is one of the things. The other good things are consistent UI. You can have consistent UI, like if your app is working on desktop or web app, you would have a consistent UI. But there's a drawback that it won't provide you the most efficient native UI as compared to the native apps. So that's a drawback there. Like you have to choose which way you want to go. And there's also one thing that I read about native apps, especially with App Store. If you have to publish an app to App Store, then you have to wait for some days. Like you have to submit the app, and you have to wait for an approval, and then you get to publish the app. And if you make any changes to the code, and if you update, and if you provide updates, you have to submit it as a version, and then you'll have to wait again for a few days to get it to update it. But with hybrid apps, what you can do is anything that's a change on the HTML part and not the native code could be just published. You don't have to wait for an approval. It can be just updated. So today I'm going to be talking about Electron. Electron is basically a library which uses web technologies like HTML, JavaScript to create native applications, and specifically desktop applications in this case. So in Electron, if you write a code in Electron, that will basically work for Linux systems, for Mac systems, and Windows systems. So how does Electron work? It's powered by Chromium. So Chromium is the open source library on which Google Chrome is built, and Node.js, it's It's an environment to write JavaScript on servers, which gives you access to file systems and networks. And it also has the native APIs for all the 3 operating systems. So that in all sums up Electron, that in all powers Electron. And we might think that is Electron being used in our daily life? Yes, it is, because all these apps are built in Electron. So the VS Code, which is my favorite. So all these apps are built on Electron, and especially the Atom. I think the Atom is the GitHub wanted to create an Atom editor. So they were looking for some options to use the existing code base to make a desktop application. So they started with NWJS kits. There was a library to create desktop applications using JavaScript and web technologies, but that didn't work out. So they created Electron. So that's how Electron was created in 2013. So let's get into the architecture of Electron. So in Electron, there are 2 main processes: the main process and the renderer process. The main process is the life of the application. It consists of all the native functions that you can access. So whatever native functionality code you have to write it in the main process. And the renderer processes are basically HTML files that just display pages. So you can say that a main process is like a window, a browser window, and renderer processes are just tabs. So when you have main process and renderer processes, you need to have some kind of communication between both of these, because renderer processes are just for display purposes. They show HTML files, and the main processes, it takes care of the native code. So the communication between the renderer processes and main processes is done using IPC channel, IPC communication, and they use an IPC channel for communicating.
What is IPC?
Interprocess communication.
I don't know all this.
Yeah.
So that again, what is it?
Interprocess communication.
Okay. I don't know what that is.
Yeah. There's not many people who, just wanted to make sure.
Not a quiz.
So, and fun fact, like if you want to run a batch process, you can basically have a main process without even having a window or anything or any kind. Like you can have a renderer process, without having any window or frameless, and you can just run something in the background, like a batch job. And so I was talking about communication between the renderer process and the main processes. So that is done using IPC connections, IPC communication, wherein the main process, the renderer process sends a message on a channel, and the main process listens to that channel, subscribes to that channel. So whenever it receives a message, it will do some functions on the main process.
This is kind of like a REST interface or the web, except it's all running locally.
Yeah.
It's like a pub sub interface.
Yeah. So to run a desktop, to run an Electron application, you need 3 of these things: Node.js environment in your desktop, in your machine, an npm package manager installed on your machine, and Electron globally installed on your machine. So I'll show a demonstration of creating a Hello World app in Electron. So as I have the npm package manager already installed on my machine, I can just start a node project by saying npm init y basically skips the configuration, and it creates the package.json file for us. So the main file for an Electron is the main.js, because it is the main process file which takes care of all the native functionalities. and you have to set the entry point for the main.js file in your package.json. So I'll cheat a bit here by copying some of the quick start code on their website.
I never done that.
I'm not notorious about doing that.
They do on cooking shows.
That's why they put the copy button right there.
Yeah. So now this has the main process in it, but it needs a renderer process. So basically a view for the desktop app. So we'll create an index file and just first we have to do npm install after creating a new. So we have to install Electron in this package, Electron package into our project because to run it as an Electron app.
Using that new node.
So Electron, if you just type Electron space dot, it will just run the application. So this is the Electron app with our index.html page displayed over there, and you can write a bunch of HTML in here and it should display it there. Yeah. So that's the Hello World app from Electron.
Did you do a refresh to get that?
Yeah, if you just do Control R, it will just render the page. So I would like to say that in this app, the index.html is one renderer process, and the main.js is a main process. So that's how both the processes are. Do we have time?
Yeah. Yeah, we got plenty of time.
Yeah. So I'll also show one more thing. I've created this project to show the inter-process communication between a main process and a renderer process. So in here, so this messages page is a renderer process, and if I click on new, so this is another renderer process. So if I type any messages in here, it should basically list that out on another renderer process. You know, that's a communication between two renderer processes. And that is done by using the main process, because a renderer process cannot communicate with another renderer process. It can, but you still have to like globally declare a global object of the main process and then use it in a renderer process. So it basically communicates by sending. I'll show it in the code.
And so you can even prove that there's hi down there in your console.
Yeah. So this IPC main dot on function, it basically listens for the listens on the new message channel for any contents that is sent. So if it receives any message, it will log that message. So this message is being logged from the main process, and then it sends the message on a new message channel to the other renderer process, which is the main. So the Windows is the main window, which is the index.html page. So it passes it to the index.html renderer process, wherein the index.html listens for on the new message channel for any messages, and when it gets the message, it just appends it to the canvas.
So I have a question. I'm looking on Slack and I don't see your message there. Why is it not showing up?
No, it's on here.
No,
You'll never present again.
No, I'm kidding.
No, it's a hybrid app, so he doesn't have to connect that to the web to do it.
That's a joke.
Can you use React or
Yeah, so Electron is basically a skeleton to build the desktop application. It's a framework to just build a desktop application, and you can attach any UI libraries on top of it. So you can use React and Angular. I have a cool application on with Electron and Angular. I'll show after this.
cool?
That robot demo that I did a while back was Electron app running React on it.
Yeah, and I can go through a little bit of things in the main process. Like it first creates a window for the process. Like you can declare a variable and create a window, and have specified the height and everything, and the HTML that you want to load in that render process and all of that. And like all the new to create. So this was about the inter-process communication between render process and main process, and I'd like to show you guys another application that I made.
So quick question. So the menu is set by the main process, and do those events go to the main process, or do they go to the render process? Your menu events, like if you click File, New, does that go to the main process or the render process?
They're all the click events are handled on the main process.
Okay.
And then the render process only communicates with any sending of data or things like that.
Okay.
And now I'd like to show another application that I made. Actually, it was inspired by Wes posting a video about Guilfoyle, having a Bitcoin alert thing. So I thought it would be a cool idea to make one of those.
It's called Guilfoyle alert.
So people who have not seen that video, it's from Silicon Valley TV show, and the character is Guilfoyle, who had created an alert application that basically tracks the Bitcoin price, and if you set a target price, it will alert with an alarm.
Is it heavy metal?
Yes.
Yeah, it's the same.
That's what it was in the TV show.
Yeah, that's what I was wondering.
So I don't know if the sound
So
will work.
everyone's heard of Bitcoin, right?
Just
Right.
start it up on your computer.
And
Have
one
to
of the
turn it
things about whoever has their microphone muted between the two, you need to turn off the microphone.
Yeah.
But make sure you don't mute the live stream.
Oh, it's going up.
But,
I think this won't work
so
without the
Bitcoin,
sound.
Bitcoin sometimes is rather volatile.
Well,
so
we'll
it's
play on
gonna
your
move up
machine
and
though,
down
right? We can hear it in the room.
a lot.
Yeah, but the voice will
And in
echo.
the TV show, the audio kept going off about every other 10 seconds.
You can try. Is your microphone's
It
off?
was really loud heavy metal too, so pretty fun.
So I know how to fix it if you want. Launch your the mixer on your volume control and turn the volume in Chrome down. So next to your clock, you have that'll work. Pull Google Hangouts all the way to the bottom. Yep, and now you should be able to unmute
Yeah,
your
there you
system or unmute Guilfoyle right there, and you should be good to go. Okay.
I like your icon there.
Watch is gonna keep going up. I know it went down.
Can you set a decimal point too?
Yeah. So, yeah. So that is one of the fun.
And what's awesome is that's the exact audio that was in the TV show.
So this app is built. This app is built in Electron using an Angular layer on it. So I can also run this app.
So good.
Can we tweak this?
Yeah. Can you just bring it back up? Bring it back up for a second.
Yeah, just let it ride. Give us the full experience.
Nerds.
There are levels of nerdiness here. That's
I
pretty
think
awesome.
that's why you come to something like this, not for the pizza.
No, there's still more pizza over there.
Yeah. I mean, I'll have a second slice.
Are you using TypeScript too?
Yeah.
Nice.
No, are you doing audio?
Yeah. The one time we saw perfect timing with my voice in it. It always happens when you start trying to trash talk it.
Oh, yeah.
And the best part is because I have a UI layer which is Angular, you can also run it as a web app.
Yeah, this is the cool part, really cool part.
While that's booting, it was really interesting playing with electronics. You can just run node code in your
Yeah, in
inside
your
of
HTML files.
Yeah, which is really wild.
So it works as a web application and a desktop application, like with the same code. And that's pretty much it. On the summary. Thanks, guys.
Thanks,
Very
guys.
welcome.
Great first talk, Tarakesh.
I like how you said first stop. First of many.
Yep.
Alright.
Any
What's
other?
going on?
Any other?
Ah!
Not
Sorry,
even
it's just like a band-aid. It's best to pull it off.
When you're not, you just like, you
Yeah.
don't know.
So we're gonna go do refreshments. Of course, we can hang out and talk some and have some more pizza. But
But if you want something other than, now I think all we have is Bud Light.